Peace. Welcome, family. I am your host, IMAG, the STEAM MC. On behalf of Swaliga Foundation, I want to welcome you to another edition of Steam the Block Live. That's right. This is the absolute coolest way to learn about science, engineering, and digital arts. Now, today, as always, I got something really cool to show you. We've been talking all about energy. We've been learning about sound waves, and today is no different. I got something really dope. But before we get to it, you know how we always start our lessons here at Swaliga? We pride ourselves on strengthening brain health. So we always start with some form of mindfulness or meditation. So if you will, with me, we're just going to do a quick breathing exercise. What I want you to do, if it helps, you can close your eyes, but we're just going to take 3 really deep breaths, okay? I want you to take in as much air as you possibly can on the count of 3. 1, 2, 3. Exhale. One more time, take in as much air as your lungs can hold. We're strengthening our lungs. On the count of 3, take a deep breath. 1, 2, 3. Exhale. One more time, taking a really deep breath, taking as much air as you possibly can. Breathe in through your nostrils on the count of 3. 1, 2, 3. Exhale. One last really deep breath on the count of 3, taking as much air as you possibly can and hold it. 1, 2, 3. Hold it. Exhale. Excellent, excellent. Peace, family. Great to see everyone. Hope everybody's having an excellent, amazing day. That was just our quick mindfulness and meditation exercise. You know, we always do that to start our lessons just to make sure that we can get our minds ready to take on new information. Now, I got something really dope to show you today. And one of the things we have been talking about is energy and waves, okay? Sound, energy, and waves. So we're going to do a quick recap. Last time on Steam the Block, we were building instruments. So we had a bunch of different materials. We were just experimenting with different sounds. We learned about melody and we learned about rhythm and how those two things come together to make the music that we love to listen to and enjoy. This was one of the examples. This was made with basically a cup and some loose change. And over the top of the rim, we put a balloon, okay, to give it a similar feel to a drum head. And a Shake Shack, and this was similar to some of the indigenous instruments that we were looking at. I was sharing some of the instruments that I like to collect with my travels. It's an example of a drum that was handmade in the Dominican Republic. Now these are things that you can do at home, so I hope you're still working on your instruments, and if you have already, I would definitely want you to send us pictures, send us videos of you playing your instruments, rocking out. Make sure you're connected with us at Tribe Swaliga, okay? Now, we also learned one of the most important things that I've ever learned in my life, and that is the engineering design process. So from now, you'll hear me keep reminding you of that, keep reiterating it until you have it committed to memory, because this is something that you can use whether it's in school, academic related, or in everyday life. It's just about solving problems and being a better critical thinker, okay? We're strengthening that brain muscle. That's what we do here at Swaliga. So really quickly, the engineering design process is summed up in one word, the acronym DIVE, D-I-V-E-E, DIVE. And you might hear me say divvy, divvy, what? Say divvy, divvy, who? Say divvy, divvy, what? Say divvy, divvy, you? Divvy, divvy. And those letters stand for the words that are involved in that process. So we'll go through it really quickly just now. The first letter, the first step that we do in the engineering design process is to define the problem. That first letter D stands for define. Next, we imagine, we brainstorm as if there are no limits. Remember, the sky is not the limit. There are footprints on the moon. After we imagine, we get our vision. That's when we get our plan. We make our prototype sketch. We put it on paper so that everybody on our team can see it. After we get our vision, we execute our plan. We execute our vision. I like the analogy of a football team huddling up on the field. They get the play from the coach, and then they say, ready, break, and then they go execute the play. Absolutely. And then after we define, yes, imagine, yes, vision, yes, execute, yes, then the last step, we enhance. And we learn that that's just a fancy word for making it better. Engineers are always thinking, looking at how we can improve or make things better. And that takes us back to the beginning of the process because we redefine the problem. Okay? Now that's Divi. You'll hear me keep saying that because that is so important. That is literally the most important thing that we learn. I like to say I could teach you how to build a robot or how to build a rocket ship, or I could just help you become a better problem solver, and you can do all of those things and some things that we haven't even seen yet, which is the goal here. So today we are going to be taking a deeper dive looking at sound energy, okay? And I really want to make sure everybody understands fully what we mean when we say sound energy. We've been talking a lot about pressure and waves and how they move. And I want to also say happy Earth Day to everybody that's watching this. This is Earth Day 2020. I definitely want to encourage everyone to just be more mindful. That includes everything from turning the lights off when you're not using them, not leaving the water running, making sure you're recycling. These are little simple things that we can do every single day to reduce our carbon footprint. And then what's also important about that Earth Day, we share this planet with so many other people and animals and species. Just make sure that you're being mindful of your energy, that you're putting good energy out into the world, and that makes it a better place for all of us to live. So again, happy Earth Day to everybody. And our activity today, you can do at home, which is really dope. This is something similar to what's called cymatics. I don't know if you've ever heard of cymatics. That's cymatics. And it's essentially the study of how sound waves move. So there's a lot of complex devices that are out there to help us visually see sound. If you were tuned in to Steam the Block Live, one of the first activities we did that first week in April, we made our oobleck and then we actually set it on top of a speaker and we got to watch the oobleck dance and move in different patterns, okay? This is a little less intense, definitely still just as effective, okay? The concept is the same. What I have here is a glass bowl, okay? If you have any type of bowl or pot in your house, it will work just fine, okay? We're also gonna need some saran wrap or some cling wrap, okay? If you have that at the crib, that's gonna help form our plate. And then that will do just fine, but if you do have rubber bands, this will help create that seal. We need to create a vacuum seal, so rubber bands will be useful as well. And that's essentially it. What you'll also see us using, we have some sugar right here. Domino, if you're watching this, don't be afraid to throw us the sponsorship. We'll have sugar, but you can use any substance that is light enough to move and that you can have a little bit of. So for example, salt will work similarly if you have sand or even if you have rice. That will get the same effect that we're looking for. Today we'll be using sugar. And I think that's it. We'll also be using a little bit of water, but that'll come later. So I want you to get your materials. What I'm gonna do really fast. Okay, we're organizing our materials here. For some reason, I got the drone sitting in the measuring cup. Okay. All right, bear with me for one moment. We're gonna get one more material that we will need. That's super important. Okay, I'm reloaded. All right. We gotta have the music. We need music. That's like one of the most important things that we need, okay? We like to listen to music. We like to dance on this show. And you'll hear me talk about STEAM education a lot, right? It's become a buzzword now, but I want to make sure everyone truly understands what we mean when we say STEAM education. Music is an important part of that. Whether you're in the classroom or whether you're at home, you'll hear us playing music while we learn, okay? It stimulates the brain muscle, gets our juices flowing, and it creates that certain vibe, that certain environment that we need. And we'll talk about what that means in our experiment today as we look at how sound actually transmits energy, okay? Sound is a way that we transmit energy. Now, what we're gonna do first, so I'll be using a Bluetooth speaker. If you have a Bluetooth speaker, this will definitely make the activity that we're about to do a lot more visual. If you do not have a Bluetooth speaker, it is okay. You can still do this activity. For our purposes, I'm gonna set our speaker in our bowl here, okay? If you were locked in with us on Monday, then you saw how we were experimenting with putting a cell phone or putting a speaker into different bowls made of different materials. We had metal, we had glass, we had plastic, and we saw how that amplified the sound, okay? That was something that just basically illustrated how that sound, that energy bounces off of the surface and can be amplified to be louder, whether or not you have a speaker to amplify it. What we're gonna do today, I'm setting the speaker into this glass bowl again. And what we're gonna do is take our cling wrap, our saran wrap, and we are going to put that over top of the bowl and seal it, okay? And we're gonna turn the music out while we do it too. Yeah, shout out to the tribe, man. If you're just tuning in, we want to welcome you to another edition of Steam the Block Live. Today we're taking a deeper dive into sound wave energy. Sound wave energy. I want us to really understand that concept because it affects so many things in our everyday life. Okay? This same concept affects even the weather. You might hear the weatherman say, yo, there's a low pressure system coming in, or there's a high pressure system coming in, it's about to rain, okay? That pressure is the exact same type of energy movement that affects sound, okay? And we're gonna help you make those connections right here on Steam the Block. Now what's important, as you're putting the saran wrap over top of your bowl, you see I just have a regular glass bowl. And again, you can do this same thing with a pot. If you have a pot in your house like this, okay? You wanna make sure that the saran wrap is as tight as possible. You wanna pull it taut so that there's no wrinkles on the top surface. Kinda like the head of a drum. How we saw our drum? It's flat, it's pulled tight against the rim. We want it as tight as possible. Okay, kind of like our eardrum that's located in our inner ear, connected to our ossicles that helps us hear. All right, that looks pretty tight. What y'all think? Yeah, no wrinkles. All right, and then you want to crease it. You want to bring the saran wrap, the cling wrap, as tight as possible. Cling it to the bowl so that no air gets in. And what we're gonna do as well, I'm gonna put a rubber band around it just to seal it even more. That hurt. Be careful when you move in these rubber bands. Okay. Swaliga, baby. So for those that don't know, the word Swaliga, and you hear me say that all the time, the word Swaliga is a tribal word from the island of St. Martin. It means passion. It speaks to the passion of the people. And what we do as an organization is help young people find their passion, help people in general find something it is that they're passionate about, something that they love to do, so that you can then take that to the next level. And we do that through STEAM education. So I always talk about how music is one of my passions, okay? And it relates to everything that we do. So what we're looking at today is, and that's coming out of our bowl. The music that you're hearing, there's a speaker, okay? So we're looking at music, but more specifically, we're looking at sound wave energy, okay? We want to see how sound moves. Have you ever seen a sound wave? If you've been watching Steam the Block, I know you got a glimpse of one, but I mean like in everyday life, have you seen a sound wave? If somebody was like, yo, can you draw a sound wave? Or if somebody was from another planet and they came here and was like, yo, what does sound look like? What would you say? What does sound look like? That's what we're gonna take a look at right now. So what we're gonna do first, I'm gonna set our bowl, our speaker to the side, and we gotta do our quick recap. I gotta show you this. Remember, sound waves move in what we call longitudinal waves. We say it's cool in the flow, Say it's true in the flow, We say moving like a sound wave, longitudinal. Our slinky moves in a longitudinal wave, which is a fancy word for a straight line. If you've ever skipped a rock in a pond or dropped a pebble in water and you see that ripple effect, you see those ripples spread outward from a center point, sound moves very similar to that. So if I pull back the rings of this slinky and I let it go, you see the slinky contract and expand, and it moves that wave. That energy translates all the way from this end all the way to the other end of the slinky. And that is a wave. Similar but different from the water waves that we're used to seeing, okay? That up and down motion, that is more similar to how light moves. Light is a transverse wave, and we'll talk a little bit more about that in later episodes. Light is a transverse wave, and that is the fastest thing that we know about in this universe, okay? So, going back to our bowl here, for those that are just tuning in, we're learning about sound energy, and we're going to take a look at what sound actually looks like. Now, I got a regular glass bowl. What I did was put a Bluetooth speaker inside of it, and we covered it with saran wrap, pulled it completely tight over the rim, and sealed it with a rubber band. Now, what we're going to do is sprinkle just a little bit of sugar. Now don't go in the kitchen using up all of mom's sugar. We only need a little bit. Don't use all of the sugar in the house trying to do this experiment. You see, I'm just going to sprinkle just a little bit. Less is more. Okay. Sprinkle some sugar on top of there like so. Can y'all see that? Nice. Excellent. Okay, now after we add our sugar, the first thing we want to look at, we learned that sound is a vibration. It's a vibration. Sound is a vibration. It's literally just vibrating air. And yet it's all around us. Think about how complex our ears and our mind have to be to decipher all of those different vibrations and frequencies that we hear every single day. So this sugar on top of the bowl, okay? I want you to imagine with me for a second, this represents what we would consider atoms or molecules, little tiny pieces of matter that we're made up of, okay? Now, right now, it's just chilling. It's at rest, okay? Peace. What up to the fam out in South Africa? I see you, DJ John Terry. This sugar is at rest. It's chilling right now. Now, what we're going to do is see if we can get it to move using sound energy. I'm not going to pluck it. I'm not going to blow on it or anything like that. We're going to get it to move using this same vibrational energy that we're talking about. I'm going to illustrate it for you, okay? So let's see. It's moving a little bit, but not really. That's not a lot of energy. What I'm doing is vibrating my vocal cords. Okay, that's how we're able to speak and to sing and to rap. My vocal cords are vibrating, and I'm translating that energy. Moving, but not quite enough, okay? And that's what we're getting into with amplitude. Now what we're gonna do, this is gonna be a little loud, so if you have your phone up or close to your ear, I will pull it away, because this is gonna sound like when they used to call people and let them know it was time for dinner or time to come in the house. We're gonna try to create sound waves by making a vibration on this pan and see if those waves will bounce off and move our sugar here. Now, we're just experimenting. That's what we do. We're thinkers, we're engineers, we're scientists. We experiment so that we can see these things in action. Y'all ready? Did y'all see that time? Throw me a thumbs up or a sound wave emoji in the comments if you can see the sugar actually moving. Notice I'm not blowing on it. I'm not moving the bowl. I'm not tipping it so that the sugar moves. I'm literally just creating waves on this pot that are bouncing off and vibrating through the air to move this sugar. Watch it one more time. Watch your ears too. Now you can see it dancing around a little bit, okay? Can y'all see that? Do it one last time. Excellent. Okay, so if you don't have a Bluetooth speaker, you can do this same thing. Again, you literally only need a bowl, something that you can cover with saran wrap to create your plate, okay? And then you'll need, I use the rubber band to seal it because you're going to keep it as tight as possible. And then you're going to put sugar or salt, whatever you have access to in your house. Be creative. Rice will work as well. Okay, you're going to put that on top, and that represents the molecules and the atoms that are moving as a result of the sound waves. Okay, now what we're going to take a look at right now is what happens when we actually increase the energy. Okay, what happens when we increase the amplitude of these sound waves? How does that affect our sugar, our molecules? Okay, now I mentioned earlier a word called cymatics, C-Y-M-A-T-I-C-S, for those taking notes, C-Y-M-A-T-I-C-S. Now, cymatics we have here is literally meaning wave. It's a subset of modal vibrational phenomena. Now, this is an apparatus that can be created which helps us to understand the elements of vibration. Now, all of those fancy words just basically means that it's the study of wave motion, and particularly sound waves. Now, if you scour the internet, if you YouTube it, if you search cymatics, you'll see some really complex devices and tools that are out there. This is our homemade version of cymatics. This is a plate that you will see that's going to help us visualize what this sound looks like. Now, remember, we're imagining that these waves right here, or this sugar rather, is molecules and waves that we can see, okay? So what we're gonna do is turn it up just a little bit. Now, keep in mind, the sugar is chilling right now. Can y'all see that? It's just chilling. It's at rest on top of the bowl. The party is pretty dry. You know, everybody's just kind of standing around on their phones, okay? Now we're going to add some music, and let's see if we can get our molecules to move around a little bit using sound wave energy. Here we go. Look at that. We're at about half volume right now. You see that? The molecules are moving in a particular pattern. They're dancing to the beat. Notice they're jumping. Listen. Can y'all see that? Drop a thumbs up or a wave in the comment if you can see the sugar moving to the beat. The sugar is moving right now to the beat. See it jump when that bass drum comes in? Yes, exactly. Gamma Ray said moving a lot more on the lower frequencies. That's absolutely right. When the bass hits, it jumps. See the jump? Okay. So I'm going to turn it down a little bit again. That was excellent. Excellent observation. Gamma Ray said they move a lot more on the lower frequencies. Okay? Those bass frequencies, okay, they vibrate a little bit different. Okay? And if you were noticing, that sugar actually jumps up when those bass frequencies hit, because they vibrate a little bit differently than the higher frequencies. Okay? Excellent, excellent. John Terry says the lower the frequency, the higher the amplitude. The lower the frequency, the higher the amplitude. Now that's true with most music. That's true with most music. You'll hear like an 808 or even like a bass line, okay? It vibrates at a higher amplitude, okay? Sometimes we'll turn up the bass because that's what's driving the song, right? And those higher frequencies, like the melodies that we were talking about, those blend in but aren't necessarily vibrating with the same amount of power, okay? It's like if you think about a voice, if you think about somebody's voice trying to get your attention, would you get somebody's attention faster or from farther away with a higher pitch voice? If you were talking like this, like really low, not yelling, but just talking with a higher pitch, or if you were talking with a lower pitch and you were louder, that is what we're seeing right now, okay? That lower frequency is able to translate more energy. Now, I'm gonna do it one more time. We're gonna see if we can make these jump, and then we're gonna switch it up a little bit. Watch this. Now, another thing I'm noticing was interesting. It may be hard to see on camera, so we'll have to show this in another video on YouTube. There's a small ring forming here of just like dust, just powder from the sugar moving in a certain pattern, okay? And it's really cool. Not only is the sugar bouncing at the same beats per minute, the same BPM as the music, but it's also moving in a very specific pattern, okay? It's moving to the same frequency of this music. And that's what we talk about when we mean the music and the things that we listen to are frequencies of energy that we're taking in. Watch it, look. Nothing with person never see. I'm nothing with person never see. Forget it, I say bashi. Money soon expect. Take our body and I take her to the person. So we just partying right now. The sugar is moving around. You see why our party needs music. Shout out to all the DJs. Look. Watch this. What we're gonna do now is see if we can pull up a low frequency generator on YouTube. Now there's a lot of apps out here that do this. It's what's called a frequency generator. But for now, we're just gonna go to YouTube. Let's see. Now these are low frequencies. You can hear it almost sounds like a hum. Can you hear that? What I'm gonna do is add more sugar to the middle of our plate. All right, so we're seeing it jump. And you're seeing that it's moving to the same vibrational pattern because it stops for a split second and then it jumps again. Watch it. See that? I'm not blowing it. I'm not moving it with my hand. We're just letting it vibrate from the sound. Now, let's see if we can pull up a high frequency generator and let's experiment and see if we see any differences. Again, and we're just talking about frequencies. If you were tuned into a previous episode of Steam the Block, we learned that frequency literally means frequent. So if you understand that somebody might say, yeah, I go there frequently. That's just how many times something happens. So when we say high frequency, what we're saying is that wave is going up and down a lot of times. There's a high amount of wave formations. Now, if we say low frequency, then that means there's a low amount of times that wave is happening. It's a longer wave, okay? And that wave is able to travel farther. And then we learned that radio waves are low frequency waves. That's why they're able to travel many, many miles from the radio station to your ears, okay? Those low frequencies. Now, we just heard a low frequency generator. What we're going to do is pull up a high frequency generator. Now, this is from about 20 hertz. Turn it down. I don't know how high this is going to be. So it's moving up the scale. It started at 20 hertz and it's getting audibly higher. We're at about 35 hertz right now. And hertz is just the measure of frequency, okay? Hertz is just the unit of measure for frequency. We're at about 50 hertz. You hear it powering up. It sounds like a device is coming on. We're at about 100 hertz right now. We're powering up. We're at about 170 hertz right now. It's going crazy. It's going crazy. All right, that's really loud. We're at about 440 hertz. So we're getting into it started off so low at 20 hertz that it's almost inaudible to human ears. It's hard for us to hear that. You may have heard that dogs have a lot more sensitive hearing. Okay, that's why we're able to use things like dog whistles that only they can hear. Just like light, there's only a certain amount of waves that our ears can hear. Otherwise, our eardrums and those bones that we learned about, what's the smallest bone in the human body? Yep, the stapes. That tiny bone can only vibrate at a certain frequency. So if it's beyond that, we literally can't hear it, okay? But we're learning that sound is literally just vibration. So we did high frequency, we did low frequency. What I'm gonna do now, we've seen it with a solid. Sugar is a solid form of matter. That means that the atoms, the molecules are locked in tight. What do you think it will look like if we put liquid on top of our plate here, okay? We're learning about cymatics and we're looking at the study of sound waves. What do you think will happen if we put water? We saw the solid, the sugar, dancing around, okay? Our friend said sharp pulse frequency vibration. Yes, those are all excellent words. Excellent, excellent. We saw the sugar, which is a solid, dancing around to the beat. Down. It was going up and down. What do you think will happen if we put a liquid on top of our plate here? Now, what I'm going to do, I'm going to take this sugar off. And you see it was moving to the sides. What I would recommend when you do this at home, as you're pouring it, notice that I pressed my finger in the middle of our plate just slightly so that the sugar would gather in the middle. We want it to gather in that center point right above the sound source, okay, so that it could spread evenly, basically, okay? So we're going to take the sugar off. Okay. Try to get most of it. And in the meantime, we are going to play some more music. Yes, here we go. This is Steam the Block Live. We're looking at sound waves. We're gonna get right into it. Okay. So, and I'm throwing a lot of information at you, but we're talking all about sound wave energy. Now, we saw what happens when we put a solid on top of our plate, okay? That is one example of what happens. Now, we're going to experiment with what happens when we put a liquid on top of our sound plate here. So I'm just going to slowly pour it. And we're going to let those water molecules gather in the middle. Just enough. So if you remember the episode where we learned about molecules, we learned that water molecules like to stick together. That's like hanging out with their friends, right? You like to stay in a group. Yeah, you remember that one. So those water molecules right now are forming a puddle. They're just staying in one place, not going too far from one another. And that is about all that we need. Can y'all see that? I'll move it back just a little bit. Can y'all see that okay? All right, so we got our water right here. And what do you think is going to happen? When we turn this speaker on, we saw the sugar get to dancing and get to moving around. What do you think will happen once we turn on the vibration or the sound over top of our water? Now, this is a liquid. So we learned that liquids are a little bit farther apart than solids, which allows them to take the shape of whatever container that they are in. Okay. EJ Gamma Ray says, oh, it's going to get jumping. Right. So we learned that us as humans, as Homo sapiens, we are more than 70% water. Our bodies, our organs, we are more than 70% water. But we're also solid and gas, okay? We have bones, we have air inside of us. We are all of these things, okay? He says it's going to get jumping, but the pattern will be more uniform. That's an excellent hypothesis. Now, I'm going to do my best to make sure I get this close enough to the camera so that you can see this, because this is really cool. What we're going to do is turn on the music right now, okay? And we're going to see what happens when the vibration comes into contact with this water. We got like a little puddle of water, if you can see that clearly, that's sitting on top of our cymatics plate. and we're just gonna crank it up. Let's just see what happens.
We never regret. One love no get shit. No matter the case.
I'ma bring you closer. Watch this.
My sweet bass. My love no get shit. For you all day. Every night, every day, you gon' need my baby to call on me, close to me, yeah. By the time,
it's jumping, watch this.
Make you fall for me, oh yeah.
Alright, I'm gonna pause it for a second. Did you see the waves forming? There were literally, yeah, he said they swag surfing. The water molecules were literally moving to the beat. They were forming waves that matched the frequency of the music. You see, right now it's at rest. The water molecules are just chilling in a puddle. As soon as we turned the music on, they started to form wave patterns. And that is literally what those sound waves look like. We learned that sound is a frequency, it is a vibration, okay? And each sound is different. Just like everybody has a different voice, just like some songs sound different than others, those are all different frequencies, meaning that wave will form a different pattern, okay? So we're gonna go to another song here. We're gonna switch it up. And I'm gonna bring the camera a little bit closer and we're gonna turn it up. It's not all the way up right now. We got it all the way up. Y'all ready? Y'all ready? We're watching the sound waves. Look how it gets still and then brightens up again. Drop a wave in the comments if you can see that. Drop a wave. Look at that.
You know the money you take up police. Me at the life you can.
We getting wavy. What's up, LV? Yes. I'm gonna pause it right there. Yes. LV dropped the wave. If you just joined us, welcome to Steam the Block Live. I'm your host, Image. We're looking at sound wave motion. So literally what you're seeing is the result of this song playing through the speaker. We have a bowl. And again, I encourage you to try this at home. You got to see this up close and personal. I have a glass bowl here that we covered in clear plastic saran wrap. And then we just put a rubber band around the bowl just to make that tight seal. We created a vacuum. And this is similar to what's called cymatics, or the study of sound wave motion, okay? And then what we did, we tried sugar first. So we got to see what a solid looks like. Now we poured a little bit of water on top of our cymatics plate. And we're literally watching these water molecules dance. We're having a party. They're moving to the rhythm of the music, okay? As the music is playing, you'll notice it goes from at rest, just chilling like that, leaning up against the wall in the party, just chilling, to when the music actually hits, that vibration is making it move. So we're gonna turn it up one more time so that you can see it. Watch how the water molecules react to the sound wave energy. We learned that everything is matter and energy. The water in this case is the matter. Those are water molecules. And the energy from the sound is moving that matter around. That's bars too, by the way.
But I just pray you the money on your mind.
I'll bring you closer.
So my baby make you no good dollar, no good dollar. When we get to the enter body, all the girl and go shake their body, they go shake their body. Oh, you have
The chairman. Yes.
You know the money you take up police. Me they love you gone.
Shout out to
So
Berna.
they sing, they feel the pulse. Look at the people jump around. Making the listen well.
Making the people jump around. Making the water jump around.
No joking around. Listen, make I tell you what it's all about. I know you tell you I see what I think.
Let's add a little more. Let's see what happens. Add a little more.
Oh yeah, look, da da da. Look, da da da. Say so my picking with the para with the da da da. You know shall ba ba ba. Oh look, da da da. Look, da da da. Say so my picking with the para with the.
Real quick, because I just saw this, I want to point this out too. Notice, when I add more water, one of the things that we learn, peace. What up, G? One of the things that we learn is that when we add water, those water molecules like to stick together. So watch, as it's vibrating, I'm going to pour a little bit of water away from our main puddle. You see it still gathers together, okay? And I wanted you to watch how the water molecules attract and lock in. That little drop that I added is gonna add to the bigger puddle. Watch this. Sorry? Watch this. It's getting closer. It's getting closer. Watch this. See that? And join the rest of the squad. The squad linked up. Oh, look at the waves. Look at the waves. Splash, then they lock in. That's right. Woo! That was dope. That was super dope. All right, so at this point, we are taking questions. All right, we got a couple minutes left. Yes, I see the wave emojis dropping in. Y'all were able to see that? Did you see how we poured a little bit of water? We added some molecules off on the edge, on the side, and those vibrations, the more they kept moving, DJ Gamma Ray said they splashed, then they locked in. They literally started vibrating closer to the bigger puddle, and then they connected with the rest of the water molecules, okay? So that's illustrating everything that we've been learning the past couple of weeks. We learned that molecules like to stick together like most other forms of matter, and we learned that electricity or those charges between them is attracting. It's like a magnet, right? It's like those charges want to come closer to each other. Okay, we have a question. It says, if we use a more dense liquid, how would that affect the waves? That is an excellent question. I love it. We're going to have to try that possibly tomorrow. Like a more dense liquid. If you remember when we built our density towers, okay, you see all of the different colors that you're seeing? Those are different liquids. And they rise and fall in the glass based on how dense or how tightly packed in those molecules are. So at the top, you have oil, okay? And you've heard the term oil and water don't mix. That is because they have a different density. So that would be an excellent experiment to see what would happen. Right now we're using water, but what would happen if we used a more dense liquid? My hypothesis, to answer your question, and this is just a hypothesis, we'll have to prove it, is that the liquid, however dense it is, will form similar wave patterns, okay? But because the liquid is more dense, okay, we learned that vibration would have to work a little bit harder to move. But I think we would see the same wave patterns. And as soon as it connects, we may be able to even see it in more clearly defined waves because those molecules are locked in. But that is an excellent question. I think we should try it. We're going to try it here on the show. Excellent. At this point, we're also, if anybody wants to join our live and ask any questions live, we're taking questions. That was an excellent question. Gamma Ray. Okay, right now we have water. We saw what it looked like with a solid. We had our sugar on the plate at first. Now, next time we're definitely going to try some more dense liquids, like maybe like a syrup or maybe like a What else did we use last time? We had vinegar. We had dish soap. Okay, soap is like really thick, a lot thicker than water. Okay, so the waves might look differently. So that was an excellent question. We're definitely gonna try that. Okay, but for now, if you just tuned in, welcome to Steam the Block. We've been learning all about sound wave energy. We learned that energy that we take in is able to affect our moods. Humans are 70% water. What we have here is a puddle of water that's formed on our cymatics plate that we built, basically just using a glass bowl, covered it in saran wrap, pulled it very tight, sealed it with a rubber band, okay? And now we're looking at the sound waves as they are permeating from the speaker and touching our water. So I want you to visualize, use your imagination with me. That water is us. That's molecules. We behave the same way. If we're made up of the same stuff, why would we not behave the same way? Okay, this is science. So what we're going to do, I'm going to crank back up the music. We're going to watch these waves and we're going to rock out. This is Steam the Block live. Here we go. The waves moving. Yo, this is so dope. We're gonna have to try this. You gotta try this at home, and I want to see what happens. Remember, all you need, even if you don't have a Bluetooth speaker, you can aim sound waves on the top of your bowl. This is coming from underneath. You can aim it from the top as well. I don't change my energy. I don't get them for no enemy. I'll bring you closer one more time so you can see it. It's forming very unique patterns. Look at the patterns. Respect is reciprocal, even though una knows I'm special. Waves, yes. What up, Anu? We're watching the sound waves, looking at how they appear on the water. Now I'm curious. We're wrapping up here. We're looking at the sound waves. I'm curious as to what will happen if we go back to our frequency generator. Wow, can you see that? Did y'all see that? So what I did, there's a lot of free apps out there. If you want to try this at home, you can download a free frequency generator. We're on YouTube. This frequency is started. We're going to start it a little bit further back. We're going to start it at about 150 hertz. And you hear the frequency go up. And you can see the wave pattern get more intense. You see that? All right, we stopped it at about 300 hertz. Okay? Very interesting. Very interesting. Okay, so I want to thank you for tuning in to another episode of Steam the Block Live. This is the absolute coolest way to learn about science, engineering, and digital arts. We got a special guest tomorrow that's going to be joining us. Shout out to Isaiah Weatherspoon. I'm super excited. This is going to be one of our best episodes yet. Make sure you join us at 1 p.m. We're going live at Tribe Swaliga at 1 p.m. Eastern Time. Make sure you're following us. Shout out to the tribe for watching. We see you. We love you. Swaliga, baby. Shout out to the tribe all around the world. We'll be right back here tomorrow at 1 p.m. at Tribe Swaliga. Make sure you connect with us. Visit us online at Swaliga swaligafoundation.org. SWALIGA, swaligafoundation.org. You're going to want to join our mailing list because we're going to be sending out videos like this, cool stuff for you to check out every single week, okay? And we got cool activities for you to try at home. Make sure you're following us on Instagram. We post stuff like this all the time as well, okay? So shout out to you. We love you. We see you. Until next time on Steam the Block Live, I am your host. I am Emcee, the Steam Emcee. We drop bars all day. This is no TV. Whether on Facebook or whether on IG, we get the water on the wave and we make it wavy. Olay. All right, we gonna rock out and watch these waves as we vibe with the water. The water is literally vibing to the music, okay? And until next time, I'm sending strength and peace and love and good vibes, good energy to you. Pray everybody is well, stay safe, and we're gonna see you next time, all right? Peace.
I know say the time go come, mama. I know say the time go come. When you look good, fit the aroma. Mama, life not on bygone. But tell you like all the magic, tell me you best kill it go pass. Keep me jack on anybody. When no one does you. Anybody. When no the carry body. I can't something.
Yes, 10 a.m. Pacific, yes.
Respect is reciprocal, even though we don't know say special. Anybody, when no one does you. Anybody, when not the carry body. I can't something, I can't something. Go back to fele, I can't something.
Okay. I hope you learned something. I hope you had fun. See you next time on Steam the Block. Peace.